Apologies, guys. Apologies to the audience. We're having a few technical problems. We'll get started in 1 or 2 minutes.
Alessandro, could you give us a hand? We're still having some difficulty on sharing the slides out of the data tracker.
Yeah, in the meantime, I'll screen share instead, and let's get going. All right. So sorry about this delay, and welcome everyone to the GNAP meeting. We'll start with a note well. Everything we say in this meeting is subject to the IETF note well. If you haven't yet, please read it carefully and pay attention to the IPR issues that are described at length. Oh, I'm glad to see Leaf joining. Hello, Leaf. Still no audio though. No. We are also subject to the IETF Code of Conduct. In contrast to other organizations where the Code of Conduct is purely around bias or anti-bias, which is a very important issue in itself. The IETF Code of Conduct is broader, and it boils down to having respectful conversations with one another, focusing on the subjects rather than the individuals. Please read this summary on the slide, and I apologize for the font. And please go to RFC 7154 for more depth on the Code of Conduct. Still not done. We're still trying to share the slides to Meet Echo. In the meantime, for audio and video, as you can see, Meet Echo is working fine. Please keep your video off unless you're sharing, unless you're presenting. Please also use the video when you're asking questions to make for a better discussion, and make sure you're muted. But yeah, after 2 years of Zoom, you know that. No blue sheets. We've forgotten what blue sheets are by now. We do need a minute taker. And in fact, this is the point where traditionally we stop and wait for a volunteer to take minutes. we cannot move forward without minutes. And if you want to take minutes, it's much easier for everybody if you take it on HedgeDoc, which is what replaces Etherpad. So a collaborative meeting notes taker. Volunteers, please. Please either activate your audio or else just put it on the chat. This is a good opportunity if you're new to the working group, a good opportunity to get familiar with both the subject and the people. So please stand up and join us as a minute taker. I really, really don't like to call out names. Thank you very much, Kathleen.
I'm happy to help. I just have to figure out where and how. I know you posted a link, but that wasn't a clickable one. So you'll have to give me a couple of minutes to figure this out.
The link is
I'm not
actually on the main agenda where it's still called Etherpad.
Okay. All right. I have it now. I just had to click an extra button that I didn't see at first. Thank you.
Thank you.
Great. Oh, and here's Leaf.
Yeah, third browser is the charm.
Indeed. All right, and most of the session will be around the core protocol and the resource server protocol led by the editors. And then we have a 20-minute session for Denis, who has some concerns with the latest draft and has in fact published his own internet draft with his view on how this should work. So that's after we're done with the editor's part. After the GNAP meeting, feel free to join us on Gather Room 6, a good opportunity to get to know your fellow members of this community, talk to the editors, talk to the chairs. And with that, I believe by now we should have the slides uploaded. So let me see if this magic works for me. No, it does not. Leaf, are you seeing any shared slides?
I'm not.
You are not. Okay,
No.
in that case, is it Justin? Is it you who will be presenting?
Yes, I'm going to be presenting today.
Let's
so
see if you
want
can
me to
screen share.
Yeah.
Okay,
I'll
so
do
please
screen
screen share. Yeah.
All right.
And you can go ahead.
Yep, just give me a sec to clean up the desktop a little bit more, and we should be good. Okay. All right, so there's that. Should be sending video. There's the video. All right, you guys need to approve the screen share request. one sec. All right. So because of this, I'm not going to be able to see the chat. So chairs, please let me know.
Will do.
All right. Okay. So can everybody see the slide deck?
Yes, yeah.
All right. Fantastic. Okay. Hi, everybody. Good day. Whatever time zone it is for you. I've got some nice strong tea this morning, and my name is Justin, and I'm joined today with Fabian, co-editors on the draft. Aaron couldn't make it today; he had a scheduling conflict with something else. But the three editors met and went over all the content of the slides. So he's got some stuff in here that we're going to do our best to cover. The current versions of the draft are the core protocol 08 and resource servers 01. Today, we're going to go over all of the changes that have happened since IETF 111. In the core draft, that's 2 full revisions. We're going to talk through both the editorial and functional changes, excuse me, in that draft. The RS draft, we actually have not published a new revision since 111. There have been a handful of small changes and some small issues that have been addressed, but the editors looked at the diff and it wasn't worth publishing a full revision because there's not a lot to talk about there. It hasn't been a lot of focus on the RS draft yet. More on that when we get to the roadmap at the end. We are going to take some time talking about some formal security analysis that's been applied to the GNAP core protocol. And some attacks and proposed mitigations, and some of the other kinds of stuff that's happening around the protocol. All right. If you download the deck, these are our clickable links. You can look at the diffs between 6 and 8. And as I said before, the resource server draft is the same version. You'll see that most of the differences are in new sections that have been added for trust, security, and privacy consideration sections. There's other stuff peppered through, but that's the majority of the text changes that you'll see there. We have merged 32 pull requests on core and 3 pull requests on the resource server draft. In the last few months since the last IETF meeting. Again, these are clickable links in the downloaded copy. This is just in the space between the cutoff for draft publication for 08 and today. We have closed 55 issues with those pull requests, though. The editors went through, and there were a lot of interrelated issues that a lot of them boiled down to, there's this specific issue that needs a discussion section. And so that either went into privacy or security considerations. There were a bunch that were about the trust model between different parties. Now that all that's been added, we've been able to close a lot of those issues. And 5 issues closed on the resource servers draft as well. Like I said, though, no new publication, but you can see the editor's draft on the resource server from the GitHub page if you're interested in seeing any of that. All right, on to the issues, onto the pull requests themselves. So these are all pull request numbers. As you can see, most of those pull requests are what we would consider really editorial changes. A lot of them came from folks in the community. Andreas and Florian specifically have contributed a lot of little changes where the text was not internally consistent. Some things was referred to as a flag in one place and a value in another place, or there were leftovers in the descriptive text from when the normative text changed, or leftovers in examples from when the normative text changed. So lots of cleanup. There's probably still a bit more to go, but thank you so much for those contributions. They are immensely helpful for making sure that the protocol actually makes sense, and it speaks to people really reading through this document with an eye for fine details, which is a really, really important thing for this stage of the document. A handful of other things were truly editorial stuff, either typos or misspellings or formatting changes and stuff like that. We've started to use this configuration called editor config to hopefully minimize the amount of sort of spurious changes from the different editors and community contributors for things like white space changes, and the one that's always getting, especially Fabienne and I, is the extraneous white space at the end of lines. Our editors treat those differently. Our editing software treats those differently. So we were running into that a lot until Aaron added the editor config controls there, and that will hopefully clean that up a lot. We've also added a few contributors, like I mentioned, people that have been putting in this work. We are very grateful. You are definitely contributing to the specification. And I really want to say that even though all of these pull requests aren't deep technical protocol edits and things like that, these are all really, really important, for the text to actually read consistently and read well to somebody that's sitting down and using this. So thank you very much for that. And finally, the release and cleanup commit for draft 08. So functional changes in the protocol itself. The top 3 bullets are, we're going to talk about all of these, but the top 3 bullets are the new major sections. There's trust relationships, and Fabian is here on the call. He'll be talking about that and how that works. There's the security consideration section and the privacy consideration section. There's also a change that we've made, a couple of changes that we've made to how the subject identifier is handled and how the client instance identifier is handled. These are largely continuations, as you'll see, sort of building on previous work and making the protocol itself more internally consistent, and making use of and taking advantage of aspects of the protocol that we have now that we didn't have in the past, to make things make more sense to somebody, hopefully make more sense to somebody sitting down and implementing it. Fabienne, you want to go ahead and talk about trust relationships, please? Fabienne, are you here? All right, I'll try to, I'm not hearing Fabienne, so I'm going to talk through this best as I can.
Hi.
Oh, is that you? Go ahead.
Yes.
Oh,
Sorry.
excellent. Go ahead. Yep.
I've been having audio issues.
No worries.
So yes, we've been working on trust relationships, especially since it was something that was expected for a long time, together with privacy and security considerations. So it's a new section, section 1.4, and what we've been adding is basically the details on what each party is actually doing and expecting from others. So detailing for each pair of relationships, like end user, resource owner, end user client, end user authorization server, etc., etc. So compared to the last interim discussion that we had, for those of you that were present, we actually added the end user authorization server relationship in the last draft 08. The general idea is we're actually using promise theory. So it's actually an alternative trust model to previous ISO descriptions, which is actually taking the description a bit further, in the sense that you're actually describing what each agent is promising to others, and you're building the trust relationship based on that. So that's basically the parts that you've got here. So trust is defined as an agent's expectation that a promise will be kept. Of course, there can be a lot of promises in our protocol. And so what you can do is you can actually execute each promise as a Bayesian probability. So it's not, the trust itself is not 0 or 1. It's something that you're going to build up. And that's actually more looking into reality in that area, because it's not something that's when you look at the entirety of the protocol, some parts may present some vulnerabilities, especially if you didn't implement security considerations in full. And so you can actually have something that you're going to be able to assess more generally. And what we want to do is to build formal security verification based on that. And for instance, we've got some participation that's planned for the OAuth security conference at the end of November. And so you can read through that. The entire description is available in the GitHub repository.
All right. Thank you. And the one last bit that I want to point out that Fabien touched on is that one of the best things about this theory is that it's always about these relationships between the different parties. It's not just about the parties. And a lot of the early discussions about use cases in the protocol were really about getting into what those relationships are, how they're formed, how they're modified over time, that kind of stuff.
Yeah, something also interesting is we really tried very hard not to repeat ourselves between what trust is about and what security and privacy considerations are about. So when we need that into a trust relationship pair, we actually describe, well, we link to the parts which are relevant in the rest of the documentation, in the specification. So we are trying not to repeat ourselves, which is otherwise something you would tend to do if you're not describing it like that. But of course, we are really looking into your feedbacks, but we think it's something interesting to get into more detail.
Excellent. All right. So the next big, come on, there we go. The next big section is the security considerations, which now counts to 25 subsections. And as you would expect in a protocol like this that's security focused, there's a lot of different stuff to cover here. And I'm not going to go into detail of every single bit in that section here on today's call, but we do ask, the editors do ask people to read through this section, because there probably needs to be more subsections. There probably needs to be more aspects that need to be covered about all of these different things. And the editors do know that the organization of that section isn't the best right now. I'm taking full blame for that. It's just kind of a one top level bucket at the moment. We are working on kind of organizing these into categories and things like that. But some of the larger things that covers is that even though you're signing requests, you still have to use TLS, because the signatures don't provide confidentiality in transit. But you still have to sign things because TLS doesn't provide identification, and your signatures need to be able to cover the message, the relevant message content. In order for signatures and anything like this to be trusted, you have to protect your keys. If you're sharing the keys that you're signing things with other parties, those parties can sign for you, and you probably don't want that. And also, if you're using bearer tokens, there are no signatures with it. So anybody who sees the token is allowed to use the token, regardless of the contents of the token. So this is the kind of stuff that is obvious to a lot of practitioners in our space, but still absolutely needs to be enumerated. Then there's more subtle stuff, like the crypto algorithms and the random number generator algorithms that you choose could have their own susceptibilities, their own weaknesses. For example, if you're using a bad pseudorandom number generation in order to generate some of these, ephemeral handles, like say you're using a handle-based access token, a reference-based access token, so no internal content or structure. Somebody could try to either guess or exhaust your access token space if you're not using a good, even random number generator. We also have a couple of sections that point out the ways that front channel redirects are kind of inherently susceptible to attacks like phishing, attacks like session capture, and how aspects of GNAP can combat that when used properly. But still there is this notion of you are giving away control of the system to an untrusted party for a bit and then waiting to come back. So there is inherent risk in that you need to understand before you just go start applying this. If you guys will remember, earlier in the year, we had some researchers point out an authorization server mix-up attack against GNAP, and the mitigation for that is the interaction hash in the front channel. And so we've got text now that describes why it's important to check that hash and all of the signatures on all of the various messages. Along with the keys, like I said, these need to be binned, and I'm like editing the bins in my head as I'm going through even this list. Pre-registering your keys solves some problems, but creates other problems. So just because you know a key ahead of time, especially client instances key ahead of time, doesn't mean that you can necessarily always trust it to not have been exfiltrated and copied and shared. It just moves the focus of that trust, which is something that's part of the trust theory that Fabienne was just talking about. Using mutual TLS everywhere doesn't actually solve a lot of the problems that it tends to get applied to, people apply it for. So there's discussion about that, and also different ways that TLS can be deployed. So you can deploy with a CA, you can deploy with just explicitly trusting self-signed certificates and things like that. And finally, since we do allow the protocol to touch complex things like identity assertions, processing those assertions has its own set of vulnerabilities. There have been attacks against XML DSIG, against SAML, against Jose, and if you are working with those assertions that use those technologies, then you are susceptible to those attacks as well. So somebody could do an XML fork bomb attack against you if they're just trying to get you to parse a SAML assertion and you're doing it naively. So what this basically means is that if you need to work with these other data structures and these other formats, you also have to really pay attention to all of the susceptibilities that they have and they carry with them. So there's other details, there's other security considerations in there. The editors ask that everybody please go read through them thoroughly. We have tried to add forward-facing links to the rest of the document where appropriate. So where we have a normative discussion about something, it'll say, see section 12.6 for discussion of different attacks or whatever. If there are other places that we can add those links, if there are places we can add backlinks for greater explanations from the security considerations, please help us to do that as well.
Justin, unless you have a slide about it, I think this is a great place to stop and mention the OAuth security workshop.
Oh, we don't have a slide. Thank you, Yaron. So the OAuth security workshop is an online event that's happening in a couple of weeks. I shut down my calendar so it wouldn't pop up, but if somebody has the date. This is a free online event. I will be presenting sort of the core structure of GNAP as a protocol. Fabienne's going to be presenting formal security analysis, a lot of the trust and security modeling of GNAP there. There's also going to be a lot of discussion on OAuth and OpenID Connect and related protocols. So it is a free event. It's happening in a couple of weeks. If you can make it, please do. This is a place where a lot of very in-depth sort of gloves off discussion happens in terms of like, well, if you do things this way, then it's going to fall apart. So how do we make sure this bit doesn't actually fall apart? GNAP is in a really good position to be kind of part of this community now. This is the first time that GNAP is formally part of the OAuth security workshop and agenda. And so we're in a really good position for this now because while the core protocol is fairly stable, we're not yet final. So we can still tweak things, we can still fix things, we can still call things out as we're going to be doing later today. So please make the security workshop if you can. Fabienne and I will be there. And does anybody have the date or that, or if it's in the chat, that'd be great. You can Google it too.
The link on the chat.
All right, perfect. Thank you. Kathleen, if you could add that to the notes, that would be perfect. Just the link. All right. So, privacy considerations. We are lucky in the IETF to have RFC 6973 that actually lays out topics and sort of major categories to analyze specification. And just like the security considerations, these are all things that you need to be aware of, that this is something that could happen. Sometimes it turns out this is actually something that you want. Sometimes it's something that you might not have realized could happen. So on the surveillance side, you could be surveilled by the client, you could be surveilled by the authorization server, and those can actually happen in ways that you might not realize. For example, if the authorization server, we would expect that as it's, by its nature, we would expect that to be able to know where you're making calls and things like that, because you're asking it for access tokens. But you might not expect it to have all of the exact information about like when you are making those calls and what calls you're making, because that's something the resource server might be calling back to the authorization server to get sort of policy decisions on. So we laid out that type of information, the data that you're storing, the shared references because of all of the identity stuff that can be added into GNAP, the references to user information, so an opaque identifier from an AS, if that's reused across multiple systems, and that's actually disclosing more information than you might expect it to. You might not expect two different resource servers or two different domains to know that you're the same user. And these are considerations that need to be made for pretty much all of the implementers in the system. So people who are building clients, building resource servers, building authorization servers, and the support components for each of these kinds of things. One of the ones that that shows up, and this is also going to be part of the security considerations, that if a client uses the same key to talk to the authorization server and every resource server, then all of those resource servers, even if they don't know any information about the user, they're just serving some non-user related stuff, those resource servers would be able to correlate, hey, I'm seeing the same key used for signature that you're seeing, so this is probably the same person. This is the same piece of software. And that might not be something that that the client actually wants. The client might actually want to hide that from those different systems. GNAP allows that hiding, but a developer might not realize that when they're sitting down, and they might take the easy path of just using the same key everywhere, the same identifier everywhere, all of the same sort of other information across all of these different systems. And so that's why it's important to really call all of these out for implementers to be able to make those decisions as they go forward. All right, so that's it for the major sort of trust, security, and privacy considerations sections. I will pause before we get into the more detailed stuff if anybody has questions about these major sections, because as I said before, these are the major new sections to the document. So Yarn and Leif, just let me know if anybody's on the queue or if I should move on.
Doesn't look like it.
All
Yeah.
right.
Or maybe I will ask.
Yeah.
So just to get everybody on the same page, we obviously have two protocols. You talked about security and privacy consideration, two drafts. You talked about security and privacy considerations in one of the drafts, the core protocol. Can you speak to how it relates to the other one?
Okay, fantastic question. My apologies for not bringing this up, because you made the same point at the interim, so I should have remembered this. These are all sections that have been added to the core draft. The editors have not applied this exercise to the resource server draft yet. We expect that the resource server draft will inherit a lot of the considerations from the core and be able to point back to them. But we do expect there to be additional considerations that are going to be unique for that draft, and also things that you would want to go into more detail for that draft. For example, the resource server draft defines the introspection protocol, which is the mechanism by which an authorization server would learn that a given access token is being actively used at a bunch of different resource servers. And that is a trade-off of using introspection. That might be something you actually want your authorization server to know in order to protect the users and protect the environment. That is its job. But it might also be something that you want to mask in some fashion. Or avoid entirely by not using token introspection, by using a structured token instead. There are also security considerations for if you're using a structured token, what goes in a structured token versus what you don't return. For example, I've done a lot of work in healthcare spaces where putting a user identifier in the access token is a gross privacy violation, because you do not want to allow these data endpoints to correlate a real life person against a specific medical record, or like a piece of medical imagery or something like that. And they don't need that in order to function. So all of these kinds of trade-offs need to be discussed in depth in the resource draft. So we do expect there to be additional stuff and expansion of stuff inside that draft, but we haven't really gotten to that part yet.
Okay, thank you. There's no one else on the queue, so let's move on.
Fantastic. All right, so symmetric cryptography. We had a lot of discussion back and forth in GitHub and a bit on the list about this, and what it boils down to, the way that we have it right now, is that it is allowed, but it is restricted. A lot of the reason that it's allowed is that the underlying crypto methods allow for symmetric cryptography. So it's a little it would be awkward at best and silly at worst for GNAP to attempt to disallow something like that. What we do disallow, though, is using GNAP for symmetric key distribution. So GNAP's mechanisms for introducing keys by value are only allowed to be used for public-private key crypto. And the reason for that being obvious, if somebody has your symmetric key, they can actually go and do things. You're only allowed to pass around key identifiers. How you set up those identifiers is up to you. But we have text now in security considerations, which explains some ways that you might actually want to do that. Some things you can consider, like key derivation functions in order to get to a symmetric key. So you can pass in an identifier, run that through a derivation function to get the appropriate key in the right place. You can do things like use a key escrowing service to actually do all of the crypto for you so that your code never actually sees the key and you're locked out to only do verification, for example, and you never actually see the key for that. What we wanted to make sure was that there are ways for people to do this, to not do it naively and not approach this in a way that that leads people to believe, oh, symmetric is easier, therefore I'll just do that everywhere. And we wanted to get away from defaulting to shared secrets in the way that OAuth 2 does. Now, OAuth 2 defaults not only to shared secrets, but shared bearer secrets, which is even worse. But so we're at least away from that. However, there are some big drawbacks to using symmetric crypto, but there are enough compelling use cases where it would be useful to do that. The editors are very interested to see how something like HPKE, the hybrid key thing from CFRG, wow, alphabet soup, sorry. The hybrid key, hybrid public key encryption, HPKE, there it is, could be used as a key derivation mechanism inside of GNAP, and how that could be potentially signaled on top of the existing crypto methods, because that's really a key agreement method. But we haven't profiled that. We haven't seen anybody profile that yet. I think it would be really interesting to see where that might go. So pause here for a moment on symmetric crypto.
Nobody's running to the mic.
All right. Thank you. All right, the next thing that we changed is we used to have this thing called a user handle. And the idea with this is that this was a special piece of information that the client instance had that it could send to the AS to say, hey, as far as I know, this is the same user that has been here in the past. That's something that it kind of came in from UMA and with the persistent claims token. But GNAP goes a lot further in handling the identity and user-facing stuff. What we have now is a way to exchange opaque identifiers using the subject identifier format from the Security Events Working Group. These opaque identifiers, we realized a bit ago, give us all of the power of this special user handle construct that we had previously, but without inventing something new. So what we ended up doing was we took out that part of the protocol, but didn't actually lose any of the functionality of allowing the client to say, hey, as far as I know, it's the same user, because now the client can be told, this user has this identifier according to me, the AS. And the client can just echo back, hi, AS, as far as I know, it's the same person. Now the AS can take that and as with anything in the user section, of the request, it can either trust that the client is probably telling the truth there and the client's probably correct, or it can say, I don't believe you and I need to talk to the user myself. And that's where the whole interaction thing falls through. And but this is just one of the ways that we've been able to kind of shrink the protocol a bit without shrinking what it's capable of doing. We've been able, if you've been watching the changes of the protocol over the last 6 to 9 months or so, you've probably seen we've been doing a lot of that. We've been cutting out a lot of these like little special pieces, and we've been able to use just sort of the core functions of the protocol in ways that still make sense. Part of that is that we now removed, there was this whole handle discussion because the original ID that I had called XYZ had all sorts of different handles for all sorts of different things. So this user handle is now this opaque identifier about the subject identifier. The resource handle, that now is information that comes from the resource server. And that's something that's covered by the resource server draft. Now, the last thing that we have is also no longer called a handle. It's the client instance identifier. And so we're actually wondering, could we even simplify that? We have an open issue for trying to figure out dynamic client registration management over time and that kind of stuff. This is really where this type of instance identifier really comes to play. As a reminder, this is an identifier that the client can use in lieu of presenting its key by value and all of its sort of display information by value that the AS can dereference however it likes to figure out that this is the piece of software or the instance of software that's calling me right now. So we have a way for that to be provisioned dynamically, sort of built into GNAP. But could that actually be leveraged to do things like allow the client to update itself over time, allow the client to rotate its keys over time? We'll get to that in just a moment. So we think that there's more that we can do with this that would actually simplify this entire handle discussion even further by using mechanisms that are really already built into the protocol itself. All right. Now on to the formal security analysis. This is something that that the editors received an email about. These are a couple of things that the editors received an email about. Some researchers, I'm terrible with names, but it's Florian Hammerschmidt, I think. It's not personal. I'm honestly just really bad with names. And colleagues were doing analysis of GNAP in light of a lot of analysis, basically applying a lot of analysis that's been done to OAuth and related protocols. And so with this, they have figured out that there are some ways to exploit GNAP that do carry over from OAuth. This shouldn't be particularly surprising. There's a lot of similarities. And so now it's our job as a working group to figure out what our mitigations for these are going to be. And before I go into this, I want to remind everybody that the mitigation can be a change in the protocol. It can be a behavior recommendation, don't do this bad thing that leads to this bad situation. Or it could just be a heads up, if you're going to use this option, this is something you need to worry about, right? So the first of these is called the cuckoo token attack. The preconditions for this attack are that the client instance is able to talk to two authorization servers, which in GNAP is not crazy given sort of the dynamic first nature of the protocol. But the client has decided to use the same keys when talking to both authorization servers. Again, this is a pretty reasonable, naive implementation of a client instance. You generate one key and just use that everywhere. The interesting thing here is that the client instance gets tricked into using the attacker's authorization server in order to get a token for a particular resource server. So this can happen in a multitude of different configuration ways. We saw this in various flavors of mix-up attack in against OpenID Connect, where somebody points to the token endpoint of the attacker server and the user info endpoint of the legitimate server, for example. And the interesting thing here is that this attack actually works for key-bound access tokens. It doesn't assume bearer tokens. What happens is that the attacker manages to get a hold of a key-bound access token, but not the keys for that token. And then they replay that token to the client, to the same client from their own authorization server, in order to trick the client into using that token with the key at the honest resource server for the attacker. Right. This makes a little bit more sense in a diagram. The access token here probably represents an end user that is not the attacker, but the attacker has control over the client instance in this case. So this client instance is probably something that talks to multiple users as well. Something like a web server or something like that, where it's using the same key to talk to multiple ASs. So the attacker goes and pokes the client instance and says, go talk to my compromised AS, and the client instance does so, and makes its request. And then the attacker's AS says, hey, use this access token with your key. The trick is that that access token is the token that the attacker stole from somebody else's account. Now, the attacker can't use it on their own. They don't have the keys to just start using it. So they need to trick the client instance to use it for them. So now the attacker has a client instance that's in a state where it's got the stolen access token that it's going to use with its own keys, and then it's going to use that at the resource server to get stuff representing whatever that access token was good for that the attacker doesn't actually have access to. Now remember, the attacker controls this AS in the red over on the right. So, they're not getting they're not really being prompted for approval and all of this other stuff. It's their server. And it's spitting out this stolen access token that then is getting used on the resource, which is then releasing that in the context of the client instance that the attacker controls, right? So this is a problem. The editors have looked through this and talked with us a bit about this with the researchers, and these are the proposed mitigations. Now, to be clear, we're not saying do all of these, but these are possible things that we can do. Now, the client could send an identifier to the resource server that says, not only is this the token, this is the authorization server that I got it from. This is the mitigation that is proposed in the paper on OAuth. This is a protocol change for token presentation. The client does have to track and send more data each time. And the RS now actually has to check these for consistency. So it needs to know that this is a token and that this came from a specific authorization server and things like that. That might not always be tenable for a given resource server, depending on network latencies and topologies and other things like that. The biggest downside to this mitigation is that it is a protocol change and more moving parts that would need to be tracked. The next mitigation would be to tell the client to use different keys with every authorization server. This might honestly just boil down to this is actually a security best practice. This breaks this attack because when the client calls the attacker's AS, it uses a different key. And so when the resource server sees that access token, it's going to be checking it against the key that it was issued against from the good authorization server, which the client won't be using. It'll be using a different key to sign that. And so the resource server will just naturally reject this. This is something that is mostly a security consideration, could even be normative text for, a client instance must use different keys somewhere up in the keys and security section. But for the most part, it would be a security best practice that we would tell client developers to do. The next mitigation would be for the client to have a very strong binding between a resource server and an authorization server. This stops the attack because now the attacker can't convince the client to use the attacker's authorization server. Again, this is largely security consideration. There are some discovery, runtime discovery aspects that can help this. So the RS first data flow, for example. We, the editors, would like feedback from the working group. We will bring this to the list with more details for consideration. At the moment, the editors are leaning towards adding text for the bottom 2 bullets in order to mitigate this particular attack.
Before we move on, I see that we have Florian with us. So Florian, if there's anything you'd like to add about the attack or the mitigations, can you please speak up?
I don't have anything to add. I think he explained it quite well.
Thank you, Florian.
Yep. Thank you. And just as a side note, just as we did with the mix-up attack that was previously discussed here in the working group, once this is a published paper, we will gladly add it as an informative reference in the document and link to it from the security consideration sections. All right. Next up is just an HTTP weirdness mechanical attack. It's known against OAuth 2 and is already being incorporated into OAuth 2.1. So we honestly just need to do this. If you're using an HTTP 307, there are cases where it will cause a post that was sent with a 307 being sent back to be reposted to the page that you're sent to, the page that you're redirected to. And depending on how you've implemented your site, this can leak information, including credentials, user credentials. So say, for example, just to give you an idea how serious this could be. Say, for example, you've got things set up so that you have a form page that prompts the user for, just keeping it simple, a username and password, and ask them whether or not they approve the decision. You submit that as a form. The AS processes all of that all in one go and says, yep, that's correct. I'm going to return you to the client instance, and I'm going to use an HTTP 307, and it does so. At that point, your browser could actually take everything from that form, including the username and password, and send it as a post back to the client, which means we have now leaked the end user's credentials to the client software, which is one of the main things that delegation protocols are trying to stop happening. So we need to be stricter about which HTTP things are allowed to be used on all of the redirect-based systems, and we need security considerations on that. Florian's already submitted some text for part of this. We need to add the normative discussion for this as well, and the editors need to review that PR to make sure that all of that is in the right place. Pretty straightforward attack and mitigation for this. Like I said, it's well known in the OAuth world. Not really surprising here. It's just, we didn't have text for it yet. Any questions on the formal analysis pieces before we move on?
We had a question from Padran.
Okay.
Yes, hi. I have a question on the second mitigation that you explained on page 17. So that was to basically use a different key for each AS.
Mhm.
And how would that work when using MTLS, for example? Because that's basically on the TLS stack, right? So that would mean that that the client would need a domain for each AS, right?
Yeah, so it's harder if you're doing MTLS, but not impossible, because one of the things with MTLS as it works in GNAP is that you don't necessarily have to use a CA to verify the certificate at the RS, because ultimately all that the RS cares about is that the certificate that's used is the certificate that's being presented alongside the token, right? It is the certificate that's supposed to be used with the token. You make a very good point, though, that, and I'm going to write a note right now to make sure that we talk about different keys in MTLS as part of that security consideration. Thank you for that. Because it is possible, but mostly if you're using self-signed certificates. If you're in an ecosystem whereby the client has a registered certificate or has a pre-registered key that all ASs will know, which happens in a lot of different ecosystems, then you're not going to necessarily be able to do this this mitigation, and that does need to be called out.
Okay, thanks.
All right, thank you. Great question, though. Believe it or not, as an editor, I actually really love it when people poke holes in these things. It means people are paying attention in the right ways. All right, so that brings us up to, we're at the top of the hour, and we've got some items for discussion. The editors met about over the last few weeks, and this is what we are proposing to do. So these are kind of the next major things that that we're going to be doing pretty much between now and IETF 113 in the spring, which hopefully maybe we'll see each other in person. We'll see. The biggest thing is that we're going to continue processing the issue backlog. We went through these issues and realized that there once again were a couple of sort of major categories that would each take care of sort of a chunk of issues at once. And a lot of these are stuff that's been sitting around for a long time, and we just need to make a decision, have a discussion, and move forward. Or have a discussion, make a decision, and move forward. That's probably a better word. We just, in a lot of cases, the issue is just like, should we do A or B? We need to just decide A or B, or figure out if there's a C out there. And I'm going to go through all of these now. So, oh, and by the way, please go look at the issue trackers. There's lots of good stuff in there. First off, there are a bunch of issues that amount to what you're allowed to send and not allowed to send at each step of the process. So GNAP defines an API for managing these grant requests over time. And there are a lot of things that make a lot of sense in the initial request that probably don't make sense in a continuation request, but we need to decide, is it not allowed? Is it undefined? Does it have a specific does it have a specific semantics applied to it if it is allowed? And we need to kind of come down on what makes sense and what doesn't. Because right now we've got this kind of large, there's a request object, there's a response object, and stuff can just kind of show up. And that type of definition leads to weird corner cases where you end up with combinations of things that you didn't anticipate. And we want to make sure that we don't have those as much as is possible. For example, are you allowed to send the client object on a continuation request? What does that mean? Does that mean that you are changing the display text? You are swapping out one client for another? That shouldn't be allowed, but what does it mean to even send this? So should this actually be disallowed? When you get back an interaction reference from the interaction finish method, are you allowed to send that multiple times, or is that a one-time use? Or is it the client can only send it once, but it's idempotent at the AS? The OAuth working group is actually tackling something very similar with the authorization code right now. So we're also paying attention and getting involved in those discussions, because a lot of the experience and wisdom with that is getting applied here. The interaction start methods right now kind of say that you're only supposed to do it once, but that needs to be made a lot clearer, right? We've got probable answers to most of these kinds of things. What we're going to do is we're encouraging people to go through the issue tracker. We're going to go through these and propose text to close them and get discussion on sort of what closing it in a particular direction actually means, and move it forward. So these will be protocol changes, but more so making the protocol more tightly defined to say that this is what you're allowed to do in this instance. Key rotation, it keeps coming up in all of these conversations. We don't have a solution for it yet, except that we do have feedback from the working group that this is something that we want to do. The editors have come down with what we think is a probably a good direction. And that's to tie the rotation mechanism to the key presentation type. Because the way that you do the type of multiple key presentation and sort of signing the keys and stuff like that. Ben has a post on the list from over a year ago now, I think, that talks about this. The way that you present keys in a way that is trustable is going to vary depending on the type of key that it is and the type of presentation mechanism that you have. So previously, one thing that's been kind of hanging us up is that the editors have been kind of waiting or trying to figure out if there was this like one grand unified scheme of key rotation. We think that there might not actually be, that it might be simply tied to the different presentation mechanisms, such that with HTTP SIG, you add multiple signatures and you sign the key value as part of one of those signatures, and then you signal that within the protocol itself. With Jose, you can wrap Jose objects. You're probably using JWKs as well, so you can sign the JWK values with the other keys, things like that. What we're going to do is, once again, we're going to propose text that defines these and then applies them to all of the different places in the protocol that can use key rotation. So for client instances and access tokens and grant continuation, which is a form of access token. And we're going to try to use as much of the existing infrastructure that's in the protocol as we can in order to do this. We don't want to invent a lot of special stuff to handle this if we can, because we've already got a lot of complex security pieces in place. We want to be able to use those. We want to be able to leverage that as much as we can. And so we will propose text for these over the next couple of months as we can, in order to kind of get what that actually looks like. This does also touch on the same area as before of how do you even rotate keys if you're doing MTLS. You might just be doing PKI, but if you're doing self-signed certs, how are you even going to be able to do that? We're not sure yet, but we're gonna, or maybe that's something you're not able to do in that case. If you're using that mechanism, that's a trade-off that you can't dynamically rotate unless there's a clever way to do this that we haven't figured out yet. Anyway, we're going to be proposing text for discussion on that. Look for pull requests for that. Another very big question that needs to be answered, especially in the core protocol, is what is mandatory to implement?
Sorry,
Gannett.
we have a comment from the queue.
Oh, sure.
Kathleen.
Hi.
ahead.
My thought on this isn't, it's just to hit on the key problem. Have you
Mhm.
looked at Acme? And I actually have a client draft to do code signing certificates, but it establishes different authentication mechanisms. The authors of SigStore, so it's being used for code signing certificates, are looking to add open identity into my client draft. And so there might be, while your solution is not the same, there might be enough ties that we could do something for the fast issuance of certificates. So basically they reissue, the goal for them is to have certificates that last a few seconds, so that
Wow.
in their instance, yes, and they use a transparency log, which is already present in Acme. So their goal is to have code signing certificates that are used once, right? And so there could be some ties here. So I
Yeah,
can
definitely.
hook you into that. And I actually had already said to them if they needed review on the open identity pieces, that I knew somebody, which I meant a lot of you on this list.
Yes. And I'm guessing that is the draft that you emailed me about the code and asked me to review. I haven't read the draft yet, but I thank you for that. I had not made the Acme connection to MTLS. That is a really, really good idea. So if as much as we can point to existing tools, existing structures, we should do so here. We should not be inventing special stuff inside of Canap. So thank you for that.
And I should be getting a text proposal to add what they need for open identity into the client draft. So you could even start from there and wait for them to provide something. And my child, because I'm taking notes and he's off today, is eating all of his Halloween candy. So you guys owe me a big thank you, because I'm gonna have a hype kid after this.
Good luck, Kathleen. All right, thank you for those pointers. We'll definitely look into that. I can say that Acme didn't come up when the editors were discussing this, so thank you for that pointer. We will definitely dig into that for the MTLS and really just the certificate case in general. Great idea. But this is exactly the kind of thing that this is why we want to go in this direction of having a different mechanism that's tied to the presentation type, to the key presentation type, because it allows us to do things like this, to say like, oh, you're doing MTLS, then you've got different considerations, you've got different tools that are available that aren't elsewhere. So no, that's great. All right. So anyone else on the queue? Like I said, apologies, I can't actually see chat or the queue.
No one.
All right. So Gnap is designed to be very, very flexible. Everything is, people have argued that everything is optional. But one of the key design differences with Gnap is that it is built around this whole negotiation aspect. So you negotiate sort of the parameters of the transaction at runtime, or you're able to negotiate that at runtime by saying like, this is what I can do, this is what you can do, and then you figure out the overlap. And sometimes there is no overlap, and the answer is no. But we need to answer beyond that sort of core negotiation piece. Are there a set of features? Is there a set of functionality that would be mandatory to implement? So is an authorization server required to always provide continuation, or is capable of providing continuation of a grant request, for example? Is a client instance required to do be able to do an HTTP message signature as a baseline? even if the AS can support other things. What are the kinds of things that two people building GNAP that are from sort of different spaces, what can they expect to work when they plug things in together? That's the kind of question that we need to be able to answer. We don't have anything for that in the draft right now. And there is one possibility here that I know Leif with his SAML profiles background is going to love, is that maybe we have what we call GNAP interoperability profiles. So we have the redirect-based web application profile of GNAP that says, do HTTP signatures, use the redirect interaction start and stop methods, and things like that. We already kind of described these kinds of profiles in the examples in GNAP. So the question here is not really whether or not we talk about these, it's whether or not we kind of formalize these and say that when you're doing this, if you declare you are this type of GNAP client application, this is the kind of support that you want. OpenID Connect has had a reasonable amount of success doing this with its different client profiles. So maybe that's something that we can leverage here. And MTI, of course, brings us, sorry, go ahead.
Putting myself on the queue and absolutely heads off. I think we should have mandatory to implement features for sure in the core protocol. I'm very skeptical about interoperability profiles. I think you're very likely to end up with esoteric profiles, or else not think about what ends up as your most important profile. So if we ever do profiles, maybe as a separate draft, but I don't think that's even necessary.
All right. Thanks, Yaron. And one of the other things I will say with OpenID Connect in particular, we've seen that a lot of the most successful functional profiles have actually come from industry vertical groups. So open banking initiatives say, take these specific features of OpenID Connect and use it in this exact same way. And that is our profile for our vertical and our group, for everybody to plug everything in together. That's stuff that is not controlled by the OpenID working group and OpenID Foundation. So there might be something like that that ends up happening with GNAP. We might see something else. I don't know. So this is a set of things where the editors, we are looking for feedback on if there are things that are mandatory to implement. We do think that there probably are. What are they? And why are those mandatory? What is driving this? Because we also don't want the MTI features to be things that people just have to implement and nobody uses.
And we have Kathleen on the queue.
Go ahead.
Sorry, I was also trying to write down minutes. So to tack on to Yaron's points on the profiles, there are some other protocols that have gone heavy into the use of profiles that are maintained in some central way, and it's hurt adoption. And then the comparable protocols. So the comparison here is the STIX versus MISP, and those are information sharing protocols. So STIX is a really robust and full explanation of every way you can possibly shape information to share. And because of that, there's multiple ways that you can do the same thing. And so they needed profiles. But then you have to check that, centrally managed profile. MISP went the other direction, and it has much higher adoption, where it has a really slim core, and then individual groups can create their own extension points. And that has a much higher success rate in terms of adoption. So just a consideration point, and that goes along with the theme of you simplifying and using additional constructs, right? Going more the direction that MISP went.
All right. Thank you.
Hope that was helpful.
Sorry, what was that? Oh, thought I had heard someone else. All right. So MTI leads us to very naturally to extensions. There has been some stuff that we've pulled out of the core over the last year. Said that, you know, this is really better fit as an extension. People are going to invent things that we haven't thought of here in this working group. We've left a lot of spots of the protocol which could be extended, but we don't really have discussion in the document about the right way to extend all of these different pieces. So this goes beyond the fact that we need to write the IANA registry section for a bunch of these bits. But we also need to consider how things can be extended. So for example, we anticipate that adding a new field in the request and in the response is something that people are probably going to want to do. Those are really natural places to put things. So what are the requirements for doing that? Like, you know, do we give guidance and say this should be orthogonal to other functionality that's already in there? It can't override something that's in another field. Like, how do we actually talk about that? Another thing that's possible is that defining a different data type for an existing field. So for example, this is a terrible straw man example, but for example, say somebody wants to define behavior for sending a Boolean value for the access token field in a request. I don't know what that would mean, but let's say we have an extension that does. Right now, the access token value is defined as either an object or an array of objects. So what does it mean when you get a different data type there? Do we even allow extensions to do that? Or do we lock down and say existing fields and existing data types, this is everything that's defined? We need to decide that. If you don't know an extension, are you allowed to ignore it? This seems to be reasonable until you realize that some of these extensions are going to be security focused, and therefore it's actually dangerous if you don't know the extension and follow it. But if we do have logic that says an unknown extension is ignored, that actually influences how extensions get written, such that you know, the security properties do actually get added in sort of the right ways. So Pixie and OAuth, for example, was built in such a way that if you ignore it, you don't get the benefit, but it doesn't make it worse. There are lots of different things that are sort of other natural extension points. So the end user claims, so the subject types, for example, the access data types, these are things that we've discussed that there's already text in there for, but we probably need to expand the discussion on all of these. And probably one of the hairiest bits is the whole interaction method, and specifically the combinatorics of the start and finish methods. So what does it mean when I use these start methods with this new finish method? Can I define another thing inside that interaction block beyond start and finish and hints? You know, because I feel like my extension needs to go do something else that's not one of those things. Do we allow that, or is that part locked down? All of these, the editors think that we have an idea of what the right answer ought to be for a lot of these kinds of things. That all needs to get written down, and the working group needs to discuss what we really want to do here. So as with the other things, the editors are going to be proposing text, proposing discussion on that text, and figure out if that's the direction we want to go or if we want to do something else. All right. Jose is used in exactly 2 sections in the draft right now. They're both key proofing mechanisms. There's the detached JWS header and the attached JWS header, which you use when you have a request body and you use the detached JWS header when you don't have a request body. So they really do stick together. These are the only Jose dependencies in GNAP core. So we brought this up during the key proofing discussion a while back. Should these really be used? Should these really be their own spec? And could these even possibly be used outside of GNAP? You know, these key proofing mechanisms are things that are general use. You know, we didn't invent HTTP signing. We're using that draft from the HTTP working group. This is something that was kind of invented in an earlier version of XYZ that got pulled into GNAP, XYZ and XAuth that got pulled into GNAP. And so should this be pulled out into its own thing as extensions for key mechanisms? And if so, is that in the GNAP working group? Is that its own draft? Is it something we adopt? Is it something we just let exist out there? That's something we need to decide. Back when we had the key proofing method discussion, there was not a strong feeling to keep it or to remove it. So the editors took the more conservative approach of leaving it in there for now, in order to have this future discussion now that the rest has settled more. And then speaking to what Jan brought up earlier.
Before we move on,
oh yeah,
Kathleen again.
Oh yeah, go ahead.
Sorry, I'm not more active on list because I probably could have provided some of these comments there. My take would be to include it in the draft, because then it's part of the core protocol. If you put it in a separate draft, it becomes optional. Even though you use it for other functions, I think it's important to leave in the draft. And that's a differentiator from OAuth, right? Because you'll have the security baked right into the protocol as opposed to, you know, something that has to show up in OWASP lists on how to secure the protocol and, you know, vulnerabilities with the protocol. Just bake it in.
Yep. Thank you for that, Kathleen. To be clear, the HTTP message signing and MTLS key proofing mechanisms are staying in core. There was really strong support for that. So those two are absolutely staying. All of that discussion, all of that is there. And those may even end up being what's mandatory to implement. The question is just about the two Jose-based mechanisms and not the key proofing in general.
So I guess if you have the actual function in another draft, but it's called out in the core draft that it's mandatory, but then you're creating a dependency on that other draft, right? So I think that would be the question. But I do think it's important to keep it in the core draft, either by reference as it being required that it's there.
Okay.
And then you have the dependency on publication.
Okay. All right. So just to summarize and make sure I understand it, your take is that the Jose mechanisms specifically should be kept in core and be a core dependency.
Yes, because they provide object level security protections, right? So
so does the HTTP signing.
But they're not addressing the same functions, are they?
Yes, they are.
All right, I'll have to look at the draft then.
Okay.
Sorry.
And no worries indeed. So basically, this is the kind of thing that you will be using HTTP signing or MTLS or one of the two Jose mechanisms for your key proofing for any given transaction. So you always have to use one of a secure key proofing mechanism and message signing mechanism. And there was, the editors believe that there was consensus to keep HTTP signing as an object level, sort of message level security protection, and MTLS as a socket level protection. As sort of the two core options. And so the Jose pieces are a different way to do message level protection. They have some pretty major drawbacks, but they do work. And so the question is whether we keep these bits specifically in core as options, or they live in their own draft. So we can take this discussion back onto the list, because we want feedback of what people plan to use, what people actually plan to do with this kind of stuff. And this is also going to help the MTI discussion as well.
Yeah, if I may add to what Kathleen said, and head off again, if the methods that are MTI, they obviously need to stay in the draft. Otherwise, the more content we can remove from the draft, the main draft, the better off we are.
All right. Thank you. Obviously, this needs a lot more discussion, so we will pull that into the list. Fabian has proposed, at least in the editors' meetings, that we write up what this Jose draft would actually look like, and present that as an ID, just so that people could see, like, okay, if we take this out, this is the part that would be there, and this is how we might reference it. But again, the MTI discussion is absolutely entwined with this. All right, and then almost to the end here, the resource server draft still definitely needs a lot of work. As we start wrapping up these major pieces and sort of pare down the issues on the core draft, we are going to be turning our focus to the resource server draft. One of the biggest pieces of this is going to be a token model, not a token format, but a token model that could be represented in token formats. If you wanted to have a formatted token, if you wanted to have a reference-based token, that would obviously still be possible, and the access token itself would still remain opaque to the client inside Canap, just like it is in OAuth. But there's a lot. This is just a short way of saying we know there's a lot of work to do on the RS draft still. All right, implementation status has grown a little bit in the last couple of months, but there's still a lot of people kind of poking around at the edges of this for both sort of the core stuff and the stuff around the dependencies. We will still at some point add an implementation status section to the draft. We haven't done that yet. But we also, as we kind of predicted back in the summer, the major churn of the protocol has remained quiet over the last 4 months, and that is a good sign. It's obviously we're not done, but it is a good sign that this that we're not changing out major swaths of the protocol on a regular basis anymore. So this is a really good time to keep implementing things, to keep trying stuff out, applying it to use cases, and figuring out how and where it works and doesn't. That's all the editors had. We've got about 10 minutes or so for open discussion. So I'm going to stop sharing. And oh, I think my browser crashed. Am I still connected?
Yes, you are. Yes, you are.
Okay.
Yep.
All right, so oh, there we are. Okay. It just took a while to unshare. All right. Let's see. Is there anyone in the queue?
I don't think there's anybody in the queue.
All right. All right. Well, so we know that there's a lot of new stuff in the draft. There's a lot of new text in the draft. Please read through that. Please continue to help improve that. And thank you again to everybody who has been doing so far. So I think we might be good to move on to the next section then.
All right. Thank you, Justin, and the editor team. And Denis, you're on next.
I don't know whether you will present my slide or if I can share my slide. I've never experienced that before.
I can try to share your slides. It will take me a few seconds though. But you can get going in the meantime. Wait, sorry. It's not a good day for Mitako, I'm afraid.
Would you be able to pick the PowerPoint slides instead of the PDF one?
Yeah, let me see if I can get Mitako to collaborate with anything, and now will be the, well, at least to start with, it'll be PDF, and then maybe I can switch, but let me see if I can get it to work. No, I'm sorry. Leaf, could you try on your side?
Yes, if you tell me again what to try, because I missed your audio.
Yeah, there's the middle button next to your name on the top left is share screen. And you need to have a separate application or separate browser instance with Denis slides.
I can try that to do it myself if you just tell me how to do it.
I'm sorry, Yaron. I'm dropping your audio. Your audio is dropping periodically, so you got to say that again. What do you want me to do? Share screen?
Share screen, yeah, with Denis slides.
I'm not sure this is going to work because I'm dropping audio all the time here, so this is going to be problematic. I think.
So
let me see if I can get.
Let me try again.
Let me see if I can.
I think I pressed block at some point and now it's... Oh, okay. Now this should work. All right.
There we go.
Okay, that's the PDF, which is better than nothing.
That's the PDF, and yeah.
Okay, so I have various concerns with draft 8, and I propose some way to address them. So the first real slide, which is next one, is about the fact that attributes are within the scope of the core document. There are two definitions that have picked up: privilege and access token. Privilege is a right or attribute associated with a subject, and an access token is a data artifact representing a set of rights and or attributes. Currently, the draft 8 only supports rights, which in terms of security are called capabilities. So I use the acronym capability-based access control, but not attributes. And usually attributes come with two flavors, whether they are attribute-based access control, ABAC, or role-based access control. And I propose that the support of attributes should be added to the core document. Next slide. Now, this leads to the following model, which is a model on the right. There is, in fact, the resource owner that can work in collaboration with the authorization server or with the resource server. Today, the resource owner is working in collaboration with the authorization server, and it's a case of capability-based access control. Now, when the resource owner is working in collaboration with the resource server, it's a case of attribute-based access control. So that makes a big difference between the two models, because in the model from the draft 8, the second case, attribute-based access control is not supported. Next one. So there are different reasons why they should be supported. I took a recent reason because there was a proposal for amending a regulation from the European Union that was posted in June this year. And the proposal considers a qualified trust service for the provision of electronic attestation attribute. Translated into our wording, it would mean access control that access token that contains end user attributes. And these end user attributes may come from multiple sources, which means from multiple authorization server. And the core protocol should define two fields in access token to distinguish very easily between rights and attributes. Today, the argument is that there is an array and you can put anything in the array. Every RS should be able to immediately know whether the access token contains rights and or attributes. And what is very important when you consider attributes is to define some attributes types, like what a first name, a family name, a birth date, and so on. So, an example is those attributes defined in OpenID Connect. And end user should be able to query a given AS to know which attribute types and value are known by a given AS. This is requesting end user information, not requesting RO information, not requesting user information or subject information as it is in the current draft. So requesting end user attribute is not supported currently. Next slide. Now, in order to support attributes, well, we should allow RS to indicate which attribute types, and in some cases, attribute values, should be included into the access token in order to allow a given operation on a given protected resource. This can be done using an HTTP option request. To allow end user which AS plurals are appropriate for each attribute type. To allow end user to know the reason why this attribute type should be disclosed, of course, in their preferred language. This is called a user notice. Of course, allow end user to accept or deny fetching those attribute types using their preferred language. This is called user choice and consent. Of course, to allow a client to request to more or to one or more AS such attribute types, and something which is interesting in terms of privacy, to allow client to hide to the AS the identity of the RS. Some AS may be too curious to know which RS are being accessed by their user. And this is possible using an unsigned part of the access token, as this has been proposed on the mailing list more than 1 year ago, but still not incorporated into the document. Because currently, as long as you support capabilities, you must disclose the identity of the RS. But when you support attributes, you don't necessarily need to disclose the identity of the RS. Next, please. Now, the benefit of the support of attributes. RS may trust a set of authorization server for only some types of attributes. There is no necessary to have a bilateral pre-relationship between an RS and an AS. A RS trust AS. AS does not need necessarily to trust a RS when attributes are being supported. When you are using attributes, the RO is working in collaboration with an RS. Where it's different, of course, when rights are being supported. And the AS can be kept ignorant of which action will be performed by a client and on which resources. This is an important privacy consideration. And as I already indicated, in some cases, which means not all cases, the AS can be kept ignorant of which RS will be accessed, which means that the true identifier of the RS can be concealed to the RS by the client, but the access token is still targeted to the RS. And finally, the following privacy properties should be supported: user notice, user choice, user consent, and there is a third one that some people do not like, because they want the access token to be opaque, but transparency means that the end user or the client working on behalf of the end user must be able to verify that what has been requested is really what has been obtained. And for that, the analysis of the access token is needed. Next one. Now, draft 8 make a general assumption that an end user and a RO are the same entity. However, there is a note that says GNAP makes no general assumption that they are, where unfortunately the note is incorrect. When you look at section 151, 152, and all other sections from 1.5, there is not a single example where the end user is not also the RO, and when the RO is an automated process. So this will need to be corrected. Next one. Now, trust relationship in draft 8. Section 1.4 is supposed to be about trust relationship, but in fact it is not. It is based on the promise theory, which is a 300 pages document where you can read that the promise is stated intention. Each agent defines its own valuation function of promise given or received. You have to wait on page 108 to find the first definition of what trust is. And you just discover that trust is an agent expectation that the promise will be kept. And it's a Bayesian property with a value lying between 0 and 1. So you trust to 20%, 25%, 22%. That's crazy. In the IT community, trust is a binary combination. It's 1 or 0. Either you trust something or you don't trust. And we should not mix trust relationship with vulnerabilities. Of course, there are vulnerabilities in a system, but trust remains the same. Well, section 1.4 is failing to indicate relationship that exists between client instance and authentication server, authorization server, sorry, and end user and authorization server. So the trust relationship conditions are not complete, and those that are described are incorrect. Next one. Now, on the same track, in draft 8, the link, if any, between client instance authentication and end user authentication is left undefined. How may a client instance be associated with an end user? I would guess that the editors knows that response. However, this is left undefined in the draft. How may an AS be confident that the legitimate user is using a given client instance? This is also left undefined. Now, you can find an interesting sentence on page 5 of the draft. The end user operating the software may, the word is important, may interact with the authorization server to authenticate, provide consents, and authorize the request. Hence, the draft does not require end user to authenticate. Well, a thing that I just remarked on the fly is that draft 8 will be unable to comply with a directive from the European Union, which is about the Payment Service Directive called PSD2, which requires multi-factor authentication. And how this shall be supported or may be supported is fully left undefined. Next one. Now, what is more important is draft 8 model is insecure. There is a section called Protection of Client Instance Key Material, section 12.3. And that section, in fact, is not addressing the protection of this key instance key material. Anyway, such a protection cannot be guaranteed. Even if you use a hardware security module to protect the private key, you cannot access the value to the private key, but you can still use that private key. So as soon as two client instances collaborate, the security foundation of the draft F collapses. A solution resistant to client collaborative attacks is needed and is possible. Next slide. Well, it is unfortunate that such solution is negated in draft 8. This was new text that was added. And it is said, however, note that the lack of inclusion of a user identifier in an access token may be a risk if there is a concern that two users may voluntarily share access token. Fine, then since that is the solution, since on the contrary, the inclusion of a user identifier in an access token is able to prevent two end user or two client to voluntarily share access token between them. Now, we are going to consider the addition of a new field that I call the binding user identifier in an access token that is able to prevent, in some situation, the access token from being voluntarily shared. Next slide. Now, there are two concepts to be considered before diving into the field. In fact, you can, for example, want to access your bank account. And when you do that, you are accessing what I call a long-term user account. You want some data to be kept by the bank about you when you unlog and when you relog again. On the contrary, you may use short-term user account. An example is you make a reservation without the creation of a user account. And once the session is closed, when you got your ticket, maybe sent on your email address, the RS will not maintain any information about that temporary user account. It is closed. Next slide. Now,
Kenny,
the binding,
We are at the 5 or 6 minutes mark. You may want to either wrap up and take question or continue, up to you.
Well, we can go to the next one. Well, there are 5 types of binding using identifier. And what is very important is that the 4 types are exhibiting different privacy properties. The first type is the best one because it is able to prevent correlation of end user between RS, and it is also able to prevent the authorization server to know the identity of the RS. That's the best way to do that. However, to do that, you will need a hardware security module. No, a secure element from the end user. You can have a unique pair for each AS-RS, but the inconvenience is that you must disclose to the AS the identity of the RS. And the 2 last cases are allows correlation between RS, but have the advantage to hide to the AS the identity of the RS. The 5th type is used for short-term user accounts only. Next one. So I will let you read that slide to know, let you understand how that works, but this mechanism does not protect against impersonation. It allows Bob, it prevents Bob to send an access token to Alice so that Alice can use it on her own long-term user account. And that is very important because if Bob is older than 18, he cannot transmit that access token to Alice that is younger than 18. Next one. Now, there are different legislation in the European Union, and I believe they should be considered. The first one is the GDPR. The second one is a PSD2 directive. And the last one is simply a proposal that highlights the fact that attributes are being the direction that is likely to be followed by the European Union. And at this time, none of these documents are being considered. Last slide. Now, I propose a modified model where both attributes and capabilities should be supported, where end user shall authenticate to the AS, where trust relationships are clear and understandable, and where in order to defeat collaborative attack, access token should be protected using the BUID mechanism, and in order to protect against impersonation, access token should be protected using mutual TLS with ephemeral client key pairs. And that's it.
Thank you very much. Any questions to Denis, or in fact, any other questions in the last 2 minutes? Yes, Fabien.
Yes, it's just to say that all these different issues have been discussed at length on the GitHub repository. And so, of course, if there are some criticisms to reuse and implement into the draft, we're very open to that. But most of the comments that Denis has made have already been answered. And we've provided actually the rationale for rejecting those. So, of course, we are very open to more discussion from other people in the working group. But so far, I think it's pretty clear it won't be included unless there's a general agreement on that.
Any other comments? All right. Thank you very much. And thank you all for joining us. Please, if you can spare the next half hour, please join us in room 6 of Gather. And see you next time.